Hey guys, for the few of you that did end up seeing the previous video, I'm back trying out this method of following along with the slides. Just jumping straight into it because this is a new topic. We're looking at spheres. So spheres being those three-dimensional shapes, those balls, whatever you might want to consider them as. A little bit strange to draw, but always can be imagined. With spheres, we have a completely curved shape all the way around. So regardless of where we look at it, is perfectly spherical all the way around. So, as I mentioned in the slides, it's a little bit difficult to fully get the surface of this area. So the surface area becomes a little bit difficult in understanding of how it goes through, because as our previous methods have shown, what we can typically do is cut up the shape so that we can flatten it out. But if we want to flatten out something like a sphere, if we just cut it in half, we still won't be able to flatten it completely. We have to start cutting it more and more and more. Eventually, we would end up with this kind of flower shape like this, where each of these is a slightly curved, and even then, still not completely flat shape. And we would have to just try and work with that. And of course, looking at these shapes themselves, we don't necessarily have a way to get these areas. Now, when you think of a sphere, you think of a circle. Because if you look at a sphere from any side, in a two-dimensional kind of view, it looks like a circle. So we're actually using different properties of circles in order to find our surface area as well as volume of a sphere. In this case, we're going to start off with our surface area, where we have our formula set as 4 times pi r squared. Now, where this formula comes from is a little bit kind of tricky to see, especially as to where what dimensions we have within the shape. So surface area, as we've been looking at, has our 2 dimensions. We need something along an x-axis and something along a y-axis. And that's where we get our 2 dimensions from. In this case, there's only one real dimension within a sphere. And so that's, if we can imagine the very center of all of its surface going out to anywhere else on the actual surface on it, that is its radius. So if we could imagine some line going from the very center of our sphere going to the outside of any other point, regardless of where it is, that is our radius and will always stay the same size no matter what. So this is why our radius becomes our most important dimension, because if we were to just double it and continue our line straight to the other side, we do get our diameter, but it's just 2 radiuses being put together. So we're going to focus on just the dimension of our radius as we continue on with these formulas. And so from here, in the slides, what I set the radius as was 5, because that'll be a simple enough solution in forming it otherwise. So when we have our radius as 5, when we plug into our surface area formula, we leave the 4 alone, we leave the pi alone, because in this case, of course, we are not given a value for pi, so we're leaving it as the symbol itself, but we do have a radius, which we have to make sure to square, and at this point, the simplification should come very, very simply. 5 squared just becomes 25. We have pi and 4 being multiplied to it. We can't multiply pi because it is just a symbol at the moment, so we take 4 times 25, which becomes 100 pi. and this becomes our surface area where the radius is 5. Moving on to volume, however, it has a lot of similarities to our surface area, where volume is just set that we take the same 4 pi r, except instead of being squared, we have it cubed. And of course, that is our main difference between surface area and volume, because with surface area, we always are getting the area of our two-dimensional shapes, and that's why, again, we want to make sure it always have units squared, while our volume ends up with units cubed. That's why we take the only unit within our circle we're using it, and we're squaring it. That's why in this case we're taking the only unit from our sphere, and we're cubing it. And we also have to remember that we have to divide this by 3. Sometimes you may see this formula written as just 4 divided by 3 times pi r cubed. And of course, this is also correct. These are just different ways of writing it. I prefer this particular method just because you have all the multiplication up top, and then you can divide afterwards if need be. So continuing on from here, again, the only dimension that we have is our radius, so the only thing we have to do is plug in for our radius. So our 4 stays the same, pi stays the same, and then we have 5 as being cubed. We're dividing this by 3, and then we just need to simplify our answers as such. The only thing we can currently do, at least easily, is taking 5 and cubing it, and of course that's just 5 times 5, which we know is 25, multiplying this by another 5 to get 125. We're leaving pi and the 4 as is, and dividing by 3. Now from here, this is why I like to keep these a little bit separated, so that now we could actually take these numerators of 4 and 125 and multiply them together in order to get 500 pi, divide that by 3, and at this point 500 divided by 3 is not easily divisible. 500 does not divide evenly into 3, and so we can leave this as such. If you so desire, you can simplify this further by actually dividing it, and you would get 166 with a repeating decimal of 6 times pi. And in either case, both of these answers are correct, and that is the main focus that we have with our sphere, knowing the surface area as well as the volume itself. I would say that between a sphere's surface area and volume, these should be pretty easy to remember, as they are ultimately almost exactly the same thing. The only difference is that the surface area actually has a square in order to get that units squared, while the volume has a cube in order to get that final units cubed, with a small note to divide by 3 as well. So that's all we're really doing with these spheres, as we're focusing on surface area and volume. And again, we can get a little bit more complicated in terms of partial volumes, partial surface areas. We will be going through that eventually, but for now, the main things to take from this is that surface area and volume are these formulas, and radius is your most important asset for a sphere. If you were given a diameter, you have to make sure you divide by 2 in order to get your final radius. I do hope that you all are doing well, and I hope you're not getting too crazy at home. Stay safe and stay healthy.